Hello again, everyone. Welcome to another edition of Open Dialog Wavelengths, which is our monthly video series focused on keeping you informed about the groundbreaking work Open Generation members are doing to advance 5G innovation for public good. This month, we're honored to feature the Center for Connected Autonomy and Artificial Intelligence at Florida Atlantic University, also known as FAU. In partnership with PQ's Security Technologies, Florida International University, and Open Generation member Virginia Tech is creating a universal radio adapter to enable a host of devices for IoT and other use cases to seamlessly connect and operate through both trusted and non-trusted 5G network infrastructure. Today, we're joined by Dimitris Pados, who's the Schmidt Chair Professor for iSense and the Acting Executive Director and Fellow there, as well as he's the Director of the Center for Connected Autonomy and AI at Florida Atlantic University. At FAU, Dimitris' focus areas includes communications theory and systems, signal processing, and machine learning with applications to connect robotic machines. Welcome, Dimitris.
Thank you very much for the invite. It's great to be here with you today.
Yeah, we're really happy to have you in our series of videos here. So the work you're doing, it sounds really like a very complex research project. What was the driving force or impetus to create this initiative?
Yeah, so the motivation behind this initiative, I would say, came from the NSF Convergence Accelerator program that called for proposals to develop technology to securely operate, securely communicate through 5G infrastructure. Yeah, we had this project idea in mind for quite a while, but I would say that was the final push for us to put this thing together.
That's really interesting how that came together. So when we think about all these different endpoints, why is the seamless connectivity between endpoints that are over both trusted and non-trusted 5G networks really important? What's the problem that we're trying to solve there?
Right. So 5G, 6G, NextG, whatever, promise to do it all. They promise to connect everything, people, things, computing platforms, robots, AI robots. So in particular, when mobility is involved, connected robotics, that is, vehicles on the ground and air, everywhere, seamless, secure connectivity is a must to rightfully gain the trust of the public. So that's one of the many reasons that seamless connectivity between multiple users, multiple endpoints is important, whether it's over trusted or non-trusted 5G networks.
Yeah, I think that's a really good point, because with a 5G network, we have mobility. So the endpoints are moving, the users are moving, they may be moving independently of the endpoints. And even if the endpoint is static, there's always this requirement for security, regardless of whether it's trusted or non-trusted. So being able to understand all those mobility use cases and static use cases intertwined, I imagine, is really a fundamental part of what you're trying to solve. So in that light, how do you envision trying to authenticate all these end users and devices, which maybe are in very different environments? They can be in a car, they can be in a house, they can be in the university, an enterprise, they could be on a boat. How do you see handling all that?
That's exactly right. So let's imagine a number of different users, machines, exactly as you said, connected on the network. The natural thought there is to look for any indigenous native kind of fingerprint that you can catch. This can come from the RF front of the user modem, for example, and definitely in this context, machine learning or AI, if you will have a big role to play there. So to summarize this thought, any fingerprint of any kind that we can grab might be good enough. But naturally, the thought is to look for a fingerprint coming from the RF front of each individual user modem. How do you classify based on the RF fingerprint? That's another story. We can pursue machine learning, AI classification approaches, or anything else that might come to mind. But this is what I'm looking at, basically, RF front fingerprinting. of individual user modem devices.
Right. That's actually a really interesting idea because traditional security and authentication is really based on unknown security parameters that are passed, which can also be fake. But for everyone who might be listening, you may not believe it, but radio transmitters, even though they come out of factories, they have a unique signature to them. And that's been used in different applications. So it's interesting that now you're looking at using that as part of the authentication scheme to add on to all the other security layers that are going to be used. So when we then look at ensuring the point-to-point security for, let's say, a mission critical data, as it goes across the 5G network, we talk about the authentication, but how are you going to ensure that part of the user plane is protected?
Right. Yeah. This question gets really to the heart of the project, I think that's it. And what makes us so excited about it, we're going to acquire IQ samples of the user signal at the minimum necessary sampling rate. Then we're going to post-quantum encrypt the IQ samples themselves and push them across the 5G network without ever attempting to decode, actually. Now, you can think of this as an antenna remoting kind of operation, or maybe what I call personally a spectrum transfer over 5G. So we take a chunk of RF spectrum from point A, and we get it to point B, not over the air, but through the 5G network. So this is the heart, basically, of this project, I would say.
Okay. That's even more interesting. In fact, I thought the authentication part was pretty interesting, but thinking about sending an IQ signal directly from point to endpoint without doing any processing would make it very difficult to decode. And you can still have all the other security layers and tunnels around your data as well. And that would be, I think in the post-quantum world, we need to have unique new abilities to be able to protect against data being exposed through the power of quantum computing. So the scope of your project to me seems very large. How has your team been able to divide the scope into a work plan and across all the different partners that are working on this?
It's really truly a naturally forming team with some of the best in the business in wideband RF front design, AI fingerprint classification, RF SOC development, RF systems on a chip development, and IQ acquisition. Then we have FPGA accelerated post-quantum secure encryption and data hiding. Each team member here takes care of one or two items in this row, and the whole is created seamlessly. So it's a really naturally forming team across those different arcs, I would say. Of course, the objective here is to reach the end result within a certain time period, as soon as possible, that is.
Yeah, I find it fascinating that the number of different disciplines you just mentioned in this team to be able to do something. I think this is kind of the new world we're moving into, where it's not just a radio problem or an encryption problem. You mentioned AI, you mentioned all these other team members and competences that need to be invoked to be able to create a solution now, which is kind of the world we're moving into. So you mentioned a little bit about time frame, but how long? I mean, I'm pretty excited. How long would you think it would take to complete these research requirements, and when do you think we may actually see this technology going into a commercial use case or by even the military?
Yeah, we are looking at a maybe 2.5-year horizon from today, depending on funds availability, of course. And interestingly, it is not only the feds, that is NSF and DoD, that fund or will fund this effort. There is also, I would say, significant direct interest from the industry. And in that way, this project is one of those few maybe that make me really confident that it will happen and will reach the end user soon. So I would say in a 2.5, maybe 3 years time, we will have a working platform along these ideas of this project.
All right. So that platform we can then use to try and experiment and And that'll be the proof of concept that can then be used for further commercialization. So,
right. And you can think of this proof of concept, Ajay, as some sort of a prototype that you take at point A. That thing reads the spectrum, does not decode what's happening. Again, it's not our business to decode, to get down to the bit stream. We sense the IQ stream. We sample it at whatever level is appropriate for us. We encrypt for security reasons. And then we push through the 5G network in kind of a hidden way. There are different ways to do that. You may embed the IQ stream in other media. You can just follow the traffic of other users over the network and then get them across. So a successful prototype for us will be something that really takes spectrum, IQ samples from one point and gets those IQ samples to another point, and then you do whatever you want to do with those IQ samples. We have some ideas about testing this device in certain 5G private networks, and that should be done within those 2 years, first 2 years of the project.
Wow, that's incredible. Yeah, and I was thinking that this kind of technology requires the capabilities of 5G to make it possible. We couldn't have done that in earlier iterations of cellular from GSM to wideband CDMA or LTE.
Exactly, it's amazing, isn't it? Right? We now can get maybe spectrum from one place to another or over a network, right? Not over the air.
Yeah. Yeah, it just opens up the possibilities as we continue to move forward, and even as we're talking about 5G now and what this could do, 6G is already being worked on, and there's even more capabilities around the corner at the latter part of the decade. So let me close with a last question. Florida Atlantic University joined Open Generation last fall, and I want to understand, how can your participation in Open Generation help you when you want to meet the goals of this research project and others at your school and the Center for Connected Autonomy and AI in the future?
Well, as Open Generation likes to say, to reach our 5G future faster, the key is collaboration. Right. So this project that we discussed, I think, is a good example of collaboration. Researchers and developers must stay connected, exchange ideas, discuss successes and failures. Right. And this is what Maitre Ingenuity's Open Generation 5G Consortium is all about. So I think for us, it's been an excellent platform to exchange ideas and truly build collaborations.
Yeah, I think, speaking for the consortium and all of our members, it's great to have universities because you're working on use cases that aren't in the commercial world yet, right? And being able to have the facilities like our private network to be able to test, and all of our partners that can also give feedback and work with the university students in your program is, I think, it's a nice match for everyone involved. And we even get a preview into what's going to happen in the future, assuming that the commercialization is viable after you go through all your research steps. I'd like to thank you, Dimitris, for joining us today and taking this time to talk about what you're doing at the university. And also for those who have been watching this series, this is our second in our series, and we will continue to bring interesting speakers to talk to us on Open Dialog Wavelengths that will give you some insights into industry and academia and what's going on in the 5G world that will be coming in the future. So thank you.
It was my pleasure, Ajit. Thank you.